Thanks, gents. Not specifically a presentation. As Jeff has said, this is more basically just an update to tell you where we are at this point in time. First of all, a little bit of admin. If you've got a mobile phone, please, can you either put it on silent mode or turn it off? If your phone goes off during my next half an hour, I'm giving you a brief, I'm going to call you out on it, and I'm not going to be polite either. There we go, that's about as much admin as I want to cover. So there we go. Okay, so I didn't actually intend to give this briefing about 8 weeks ago. Unfortunately, as I hopefully you're all aware, I woke up one morning in a considerable amount of pain, which then meant unfortunately that I had to miss quite a few of club meetings. But here we are. I'm actually quite glad to be able to give you this briefing this evening. So, a little bit of background. Okay, Sputnik 1, first man-made object to be launched into space for the purpose of communications, etc. Launched in 1957 by the Soviet Union. It was monitored by amateur radio operators all around the world using the 10-metre band, and it transmitted for 28 days on Morse code. And it was received by a lot of people. It also stunned the rest of the world, not including, of course, which United States of America, who were quite convinced that they at that time were the world leaders in space exploration, satellites and all the rest of it. Okay, now Oscar 1 was launched in 1961. 57, 58, 59, 60, 61. 5 years later, orbital satellite carrying amateur radio. Right, so just 5 years later, after the whole of the Soviet Union put a little bleeping object, by the way, Sputnik translates as Don?
Fellow traveller.
Fellow traveller, yeah. I knew that. Just 5 years later, a group of amateur radio operators, we can't deny they had a little bit of help, put Oscar 1 up, and that was very successful. And as a result of that, Oscar 3 was launched 4 years later. So it just goes to prove actually that amateur radio operators have been and continue to be at the forefront of satellite communications. A lot of the people who were involved in satellite communications today have their basis in amateur radio. And in fact, the UK is acknowledged as one of the leading builders actually of satellite equipment, based around the Hampshire area, and Guildford in particular. Right, AMSAT was formed in 1969 as the Amateur Satellite Corporation. And they are, essentially speaking, the worldwide body that looks after us and our interests as far as satellite communications is concerned. It's not a compulsory membership requirement in order to access amateur satellites. As we've proved in the past, you could stand in that car park out there with a Boafeng and a homemade antenna, and you could bounce a signal straight off a low Earth orbit or LEO satellite. But belonging to AMSAT brings a whole host of benefits, not least of which is actually quite a nice little magazine to read. Oh, hang on, that's the RSU bit. The difference is with AMSAT, it's not half as much as a rip-off. Oh, can't say that, can I? It's not half as expensive to belong to AMSAT each year. Okay. Anyway, Oscar 9, aka QO100, was launched in 1981. It was British built. Yeah, fantastic. Okay, so we have contributed as a country to this sort of stuff. Right, so a little bit of background for you. Okay, QO100 satellite was launched in 2018, obviously, as we all know, to a big fanfare. It was a tie-up between AMSAT Germany and the authorities, that's the only designation they've been given, in Qatar. And it's the first ever geostationary satellite communication system accessible by us. I hope you all know what geostationary means. If you don't, I'll explain it to you later. Essentially speaking, as far as your point of view is concerned, when you're stood on your feet looking up into the sky at that satellite, it appears to be stationary from the observer's point of view. In fact, it is actually travelling around the Earth. It's just at a position out from the Earth that appears to be stationary, which of course makes it very, very useful from our point of view. You don't actually have to track it. It's just where it is. Hence the reason why all the sky satellite dishes just point in one direction. Once you've lined it up, lock it down, job done. The Qataris were very, very nice in allowing us to stick, or allowing AMSAT Germany to put 2 transponders on their satellite bird. Now the QO100 designation refers to the 2 transponders which form a small part of that payload. So it isn't an amateur radio satellite, it's actually a commercial bird with a couple of amateur satellite transponders or amateur satellite equipment, including 2 transponders that's on there. It is actually, as it says, a TV broadcast satellite. A little bit more of a, I sort of, shall we say, I preempted myself with that, with the explanation of geostationary. But the first person who came up with it was Arthur C. Clarke. He of sci-fi fame. Right. So we're out at about 22,300 miles directly over the equator. It actually revolves in the same direction as Earth, which is east to west. And because it's geostationary, its orbit is actually every 24 hours, give or take. Right, this is the footprint map. You notice there are 2 lines, the green and the red. The explanation for those is on the next slide. But you can see, quite interestingly, that is the footprint of the satellite. Covers all of Africa, a little bit of South America, all of Northern Europe, or in fact all of Europe, quite a lot of European Russia, etc., right the way over to India, and right down, etc., etc. What it doesn't cover is North America at all.
That's a shame, isn't it?
Not quite sure who planned that one, but there again, I'm sure if you work out the satellite bods among this, the technicians, I'm sure we'll be able to explain why that distance gives us that footprint. But what a bloke of morale. Okay, the green line is 10 degrees above the horizon line, and the red line indicates 5 degrees above the horizon line. The satellite is accessed using a directional antenna. In our case, it's a dish. The advantage of using such a satellite is it can be parked and left in position. That's it. The signal distance travelled is a ginormous 71,600 kilometres on average. Because satellites, as we all know, don't stay still. They bobble around a bit. Up, down, side to side, round and round. Okay. For the beam width, even off the dish that we've got, which is 1.2 metres by 1.1 metres, has a beam width. It's not a straight line. It actually, like all radio signal, it spreads out the further you go. So even the fact that that satellite will move slightly in its position on its orbit, etc., it will still be with our beam pattern. Fingers crossed. The transmit and receive delay is at least 240 milliseconds, a quarter of a second return time. Alright.
That's up and down, is it?
Yeah.
Yeah.
Yeah, okay. And it does actually have a huge potential for coverage into remote areas. So this satellite being able to cover that massive amount of footprint for, as far as I can see, for like disaster relief, actually has a massive potential, particularly in ruralised areas and all the rest of it. We all know every time something really bad happens that the people that are first punting messages out, letting the rest of the world know, is us lot, amateur radio operators, because we're outside the infrastructure as such, and our systems don't rely on somebody going, oh, hang on, let me find a key. We just turn the radio on and off we go. So, you know, from loads of different ideas, you know, potentiality is huge. Right, the two transponders on there, one's narrowband and the other is wideband, and they're made use of in completely different modes. The uplink on a narrowband transponder is a 2.5 gigahertz, and it's a right-hand circular polarisation. For those of you who don't know what a circular polarised antenna looks like, there is one. I'm not going to hand it round, because that was nearly 200 quid. Well, one of you lot's going to go, stick your finger in it. So, if you want to come and have a look, after the presentation, feel free to come and have a look, but I don't want to pass it around. Okay. The downlink is on 10 gigahertz. So we're going up on 2.5 and we're coming back down on 10. That's normally beyond the scope of, I would say, about 99.9% of people's radios. In fact, I think only ICOM at this point in time are actually producing a radio that will work on these bands. And even then, you've got to spend an awful lot of money to buy the extra modules.
And it's narrowband.
Sorry?
And it's narrowband.
Yeah, it's only narrowband only. Yeah. You know, when the E100 was first launched, I personally was following the development and all the rest of it, and what struck me was the fact that there was no commercial equipment available. I mean, I had ubiquitous Boafeng, and I did actually have, or just still do have, an Arrow antenna, which is quite an old design now. Used 70 ohms 2 meters handheld Yagi for tracking low Earth satellites. But potentially for me to try and get into the big boys game was like a little bit beyond me. At the very least, I needed £1,000 plus of rotator, both azimuth and elevation, and a big set of Yagis. Don't want a problem, build them, but it was just the actual hardware commitment, and also the software. To successfully track satellites, etc., you really do need computerized control stuff. Yaesu were producing equipment and interfaces and all the rest of it for their big old rotators that were both azimuth and elevation. And you were looking at an investment of plus a couple of grand, and then you had to know how to work the software. Now I can put wires together and I can put antennas together, but software sometimes like just banging my head against the wall. I'm not a computer expert by any chance. Anyway, that was the problem. There wasn't much commercial equipment available, but very quickly, through the good services of Radcom and the old editor, bless him, sadly no longer with us, he pushed very hard for people to send in ideas, write in, give help to everybody. And over the couple of months that he did it, a lot of stuff went in that actually I believe made access to E100, particularly on a narrowband transponder, a lot more potential, a lot greater potential, a lot of good ideas going in, simple ideas as well. The narrowband uplink is between 24 and 24 decimal, 24 decimal 5 megahertz. It's a very small slot, and a downlink again is a similar sort of size. That's just what was allocated. The beacon is sending in frequencies you're keying. It's got a similar format to the other band plans, with CW at the bottom, data transmissions in the middle, and then SSB at the top. And later on you'll have the opportunity, if you haven't done in the past, to actually have a look at the ground station at Good Hilly, which is via SDR, which is receiving both narrowband and wideband signals, depending on the way you tune up and down it. Don will give you a good run through on that. It is interesting. Alright, if anybody does want to use the E100, just keep in mind a couple of things. The fact that most SSB signals are below that width. There's no FM or AM transmissions. Anybody want to hazard a guess why?
Bandwidth's too wide.
Yeah, bandwidth is too wide, and also
You only got half a meg.
Sorry?
You've only got half a meg.
Yeah.
And the whole world cheering it.
Yeah. FT8 SSC data modes are popular on there.
Yeah.
And believe it or not, I can't believe this, but it's true, Eddie, right? They run contesting on it. And I'm like, contesting off a satellite? That's got to be like the world's hardest thing not to achieve. You know, anyway, and also if you are running something like this, which is part of the equipment that I have acquired for this project, RSP1, Raspberry Pi SDR, a lovely little bit of software comes involved with it. They've actually updated it now. Lots of interesting bits and pieces coming down, not necessarily relevant, other than the fact that like you've got engineering signals, etc., etc. You know, come flash up. It's a bit like listening to the Marine Band down at Brixham, isn't it? You know, you're sitting there all day and the radio's scanning away doing nothing, and all of a sudden you get a pan, 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 and Brixham, you know, and the Coast Guard goes flying out. At which point you're looking out the window going, "Oh yeah, there's smoke over there." Anyway, so there we are. It is interesting listening to the engineering channels, etc. Right, the wideband transponder is pretty much the same sort of thing, although it's got an 8 megahertz bandwidth, a lot wider. The uplink frequencies are there, and it is mainly used for digital amateur TV. Again, so not only you've got to buy all your satellite communications gear, you're then looking at spending out another £1,000 on digital amateur TV gear. It's not something that I personally am going to explore. I think amateur TV on its own is very much a direction to go in, without then combining it with satellite communications. If anybody in the club does want to give it a bash, come and tell us. We'll plug you into the satellite system and you can play your arts content. Okay, there's also LoRa chip spread spectrum data transmissions, and you can monitor the DATV signals via the British Amateur Radio BARCC website. So if that floats your boat, personally I actually really like slow scan TV. To me it equates to fax, but there again it's a lot easier to take a digital photograph, put it onto a laptop and then just send it. We've used it very successfully at things like JOTA, where we've got the kids to make big signs and we've transmitted it around the world for them, and particularly they really like that idea. Oh, I'm going to be on the telly. We don't tell them it's like a fax, but hey, they're happy with that. Right, the wideband transponder again has two beacons, top and the bottom of the band, and above the lower beacon there are defined channels for the digital signals, TV signals. That's the only part of the satellite system where there are actually defined channels. Obviously they don't want people transmitting on top of each other, half a channel apart, etc. There's also narrow bandwidth throughout transmitting using 33K and 125 symbol rates. Oddly enough, the downlink signals are vertically polarised and the uplink uses a right-hand circular polarised signal. So you're going to need two different antennas. Right, that covers a little bit about the actual satellite itself and what you can put into it and what you expect to get out of it. What do you need to get there? Well, some equipment basically. Now you're all familiar with what's parked outside on the trailer, which is the big dish. This is the other part of it. Okay. Now you can, if you wish, go to DX Patrol in Portugal, hang them a big cheque signed, cry very hard when they splat it into your account because they've just sucked out something in the region of 1,500 quid. And you can buy yourself a plug and play system. Or you can do what Don and I have chosen to do, which is to go down the route of cobbling things together as and when we come. Okay. We would like to offer our thanks to not only the committee but the club as a whole for the support in the purchase of that, which is a 12-watt amplifier, the 2.5 gig. I will pass that round, try to avoid dropping it. I will quote Andrew here, who said that was a bargain at 200 quid because he couldn't make it for that sort of money. And yeah, we need that. For obvious reasons. Okay, 12 watts will get us up to the satellite using SSB. We're going to use significantly more power and probably a slightly bigger dish if we want to work DATV. You know, part of the reason why we're not going down that route yet. Okay, so what have we got? We've got a radio leads into an up converter. In our case, we're going to use 2 meters. Put that through our up converter, 144 megs up to 2.5 gigahertz. We will then put that into that amplifier. That will put us out to the dish. Now, we have 2 options. This is what's called a POTI. And that's abbreviation stands for Patch of the Year. That's 2 antennas combined. Transmit and receive. We did run into a slight problem because the dish that we've got wasn't designed to take this device. So we've had to come up with an adapter, which is a Polo. But we've run into another problem. Polo don't fit yet. So we're going to slice it in half, slide it on. The reason it's got a bigger hole is because I'm going to have to remove this piece of plastic. I'm not going to do it right now. Put a bore sighting laser down there, and we're going to find the centre of the dish. We know roughly where it is. We're going to line all this up, and then we're going to physically fix it into place so that...
Sorry,
Whose was that?
mine.
Al? Let's turn it off, please, mate.
Can my charity box tonight then?
I was turned off the volume.
Except notifications, but
No problem, thank you. Right, I've also acquired another dish which this fits. There are some slight interesting differences between these two. They're basically LNBs with antennas. The LNB stands for low noise block. Transmits and receives. There's 2 antennas combined. So, once we've got our signal up, we've also got to monitor our signal going up. So we've actually got to have a duplex system, which is why I've acquired that. And the plan is, oddly enough, is to run 2 satellite dishes.
Yeah.
The secondary dish doesn't actually have to be that big. All it needs to be able to do is to hear our signal coming back and our signal going up. And the reason for that is to make sure we're not transmitting garbage or our signal is not rubbish. And it is actually a requirement of accessing that satellite, and that falls has been written into our terms and conditions basically. Yeah, they've said, you know, you will be in breach of your licence if you do not do this. So that's what we're going to do. So we're going to monitor it. Okay. We also have the option to use a slightly different dish, the one that's mounted on the trailer at the moment, slightly smaller. I do know that one works because I've tested it. Right, so how do we resolve the signal? Well, there are various different ways of doing it. Essentially speaking, what we're going to do is run SDR. So we're going to have a listen through Goonhilly, which is cheating slightly, but it actually makes sense because it means we don't have to have a receive side. But that's what we're going to do. We're going to do both. We're going to monitor our signal through Goonhilly.
do you have the bias T? You actually have it? Okay. Because I could donate one, you haven't got one. Okay, all right.
Okay, yeah.
Right, okay.
Yeah, that came with all the goodies.
Right.
So you got it.
Okay.
So yeah, we have now at this point in time, give or take the coax, etc., all the bits and pieces we need, including the waterproof enclosure. So we can run SDR software, whichever you like. This punts out a signal, I believe. This one. Yeah, 739 megahertz. So as long as I tune the SDR to 739 megahertz, should resolve what's coming down. Pretty good. That's one way of doing it. There's the other option. It's basically the same idea, just a different format. Okay, that's, as you can see, it's actually a lot simpler. It is in German. We're all read German, yeah? As you can see, all the other bits and pieces are there. In this particular case, this guy was using, obviously, an IC705. We plan to use initially an 817. But there again, that depends whether I acquire another radio from Eddie. Depends. If you still got it? No, well I won't be then. Good for you, mate. Okay. So, if you wish to use this stuff at home, an 80cm dish is okay. That's bigger than your average Sky dish. So, I mean, get down to the local recycling centre with a tape measure and weigh.
Yeah.
Oh, that one!
Would it have to be the elliptical or just pure round? It's fine.
Either or. Okay, the way the dishes work is slightly differently, the way they focus the signals. Optimally, I would say, me personally, from my limited experience, a round dish. Other people might have other ideas. My suggestion is to chat to Andrew or Chris or Don about what their recommendations are and their reasoning behind it. Okay, 5 watts plus will give you a reliable SSB signal into QO100. But a 1.2 dish is necessary for DATV, minimum size. And around 120 watts is needed for video. Never thought I'd hear anybody tell me to punch 120 watts on what is essentially speaking an orbiting repeater. Goes against the grain slightly, but there we are.
Wide band.
Yeah.
Or banger.
Yeah.
You've got to take into account the dish.
Yeah.
Yeah. It's,
You stand-
Incidentally, the as an aside, if and when we do set that dish up, I request that nobody stands within 10 metres of it, right, in front. So if you can look at that, eye on, no, unless you're more than 10 metres away. It's particularly if you've not finished having kids yet. Calculated ERP is 1.256 kilowatts.
Phew.
That's sort of like microwave power. And I don't want my hearing aid blowing up in my lug-out. Don't worry, we will be putting... yeah, I've had to do the risk assessment and the RF assessment as well. And it doesn't really bode well for like public presentations. It's like, can we park it in a field over there somewhere? Yeah, it would be better to see if we can get it in the sky. Right, so where are we now? Phase 1. Relevant suitable parts of equipment have been donated or purchased. That's done. Okay, within reason. We've got a little bit of engineering work to do. Phase 2, construction and testing, is pretty much where we are now. The plan is to get that sorted out. For one reason or another, unfortunately Don and I have not been available at the same time together, along with the other members of the team, just to get this thing cracked. I'll be taking this home tonight, and I'm going to chop it in half. That took me all afternoon to turn on my lathe. That stuff, this plastic, nylon, is horrible to turn on a lathe. Okay, once we've got the thing put together, obviously, we've got a little bit of RX testing done, make sure the thing actually can hear something. We're then going to go to phase 3, so we're plugging the radio equipment in, the amplifier, etc., and making some test transmissions. Once we're happy with it, we'll start running it here. Park it up in the car park, put a load of cones out, and see if we can make people in the gym glow. Phase 4, there is an ongoing quiet discussion about possibly parking that dish, etc., in a secure location and making it available behind some bespoke software for club members to use and to access. It's just can I just say it's almost like pie in the sky at the moment because it's going to take some serious work. Need to clarify, of course, with the powers that be about remote access and power levels. But I think if we can prove that what we're running can only be accessed by club members to start with, and then other amateur radio operators that are licensed, then
Can every licence level use it?
yes, yeah, that's the point. The point of this project was the fact that there aren't many of us in the club that have got the time, or shall we say the finances or the equipment and the skills to put all this together. Believe me, this is a team effort on behalf of everybody that's working towards this, you know, to try and get this to work. So that was the major thing. I was inspired by the presentations that Don gave and Chris, etc., about satellite communications. In 1995, I spent an inordinate amount of time in hospital when I lost my leg. And one of the things I spent a lot of time reading was amateur radio books, particularly about satellite communications. Back then it was all on the 10 metre band and the 2 metre band, and the dishes were 10 metres in diameter, huge great bloody things. The chances of, you know, made out of bloody chicken wire and all sorts of stuff. The chances of me being able to put one hand together in, you know, in an army quarter is just like wasn't going to happen. But I could always dream. Well, here I am, you know, 30 years later, and you know, I'm following that dream. So, you know, never say never, shall we say. So yeah, to answer Andrew's question, succinctly, yes, everybody will be able to operate this, access this system. The idea, shall we say, my idea concept is it's on a block booking system. Sign in, your credentials will be there. Alan and Mike are putting together the club database, so you'll be recognised straight away with your own one-time password, and that will go into the system, and you will then be able to operate QO100 remotely from your home. And that is one critical point. You know, we're not going to let you do this on your phone sitting in the park. You're going to have to be at home for obvious reasons, because you have to put that data in. Okay, so almost there. Basically, look at that, the end of the presentation. But not to worry. Thank you for your attention, guys. If anybody's got any questions.
The low power stuff running 12 watts, is it?
Yeah.
This guy, that's within your licence, yeah, within a foundation licence.
Yeah, it is. Yeah.
The 120 watts TV,
Yeah.
that's slightly above the intermediate licence.
It is.
Is that still permitted?
But my take on this, sorry,
Yeah.
that is one, we're not planning to run DATV.
That's true.
But the other option, of course, is to run it under the club licence.
Exactly, yeah.
You know, under our own club
But that would be
licence.
the only restriction, is the power.
Yeah. So,
Not the gain of the area.
but I think, yeah, good point, Andrew. Yeah, but that doesn't mean to say you actually have to
But if you
use
do have a
that.
5 metre dish, of course you don't need the power.
Yeah.